All right, so here is lesson 9.3, more about slopes. All right, it says you have seen for a linear function, the rate of change is constant, right? The rate of change is constant and is equal to the slope of the line. What that means is, again, the rate of change and slope is the same thing. This is because a linear function increases or decreases by equal differences over equal intervals. Look at the graph below. All right. Over the interval 2 to 4, right? How much does the function increase? Explain. Right? So from 2 to 4, right? From 2 to 4, the interval 2 to 4, how much does it increase? Well, it goes up 1. Okay? So from here to here, it goes up 1. So what we say for that one is that the function increases by 1. The function increases by 1, right? And that is from y equals 4 to y equals 5, right? It goes from when y is 4 to when y is 5. All right, so if you take a look at number 2, it's asking you to say, well, hey, how much does it increase from 8 to 10, right? How much does it increase here, right? From here to here. Well, it's still just going to go up 1, right? My x is going to go up 2, but my y value, right, is going to only go up 1. So I'm going to say the same thing again. The function increases by 1 from, nope, that's not 8, from 7 to 8. Okay, from y equals 7 to y equals 8. The equal difference over equal intervals is equivalent way of referring to a constant slope. The differences refers to the delta y, and the intervals refer to the delta x. Equal distance over equal intervals means the change in y over the change in x, which represents slope, will always be the same. So the table below represents a function. Determine the rate of change between negative 8, 62, and negative 6, 34. All right, so I'm going to say this is x1, y1, this is x2, y2, and I'm going to say 34 minus 62 over negative 6 minus negative 8. 34 minus 62. 34 minus 62 is negative 28 over 6 plus 8, which is negative 28 over 2. And that simplifies to negative 14. All right, negative 14. All right. Another way that we, again, figured that out is that we could have used our table, right? The table, the difference from here to here is that it goes down 28. And the difference from here to here is that it actually increases by 2. And remember, there's a gap there, right? So there is a number that's in between. So if these look a little funky, that's okay. There are numbers in between. And then we just have to simplify the negative 28 to give me what I need. Determine the rate of change between points negative 1, and 1 and negative 1. Well, that's my x1, my y1, my x2, my y2, negative 1 minus a negative 1 over 1 minus negative 1. And that is negative 1 plus 1 over 1 plus 1. And so that is 0 over 2, which is 0. Is it a linear function? Justify your answer. Well, if this slope is negative 14 and this slope is 0, remember, in order for it to be a line, in order for it to be linear, the slope has to be the same. Okay? So is this a linear function? The answer to this is no. The rate of change is not constant. The rate of change is not constant, right? Doesn't have the same slope, right? The rate of change is not constant, right? Doesn't have the right constants. Constant. Another way of saying this is, again, the slope is not the same for all points. Right, that's just another way of us saying the rate of change is not constant. The slope is not the same for all points. Okay. Determine the slopes of the line shown. Right. We know our rules for these is that we just have to find what? 2 good points. Right. We got to find 2 good points. 2 good points. I got a good point right there. Let me make that a little bigger. I got a good point right there. I got a good point right there. I'm going to go ahead and just do the rest of them. I got a good point right there and a good point right there. I got a good point right there in the origin. And I got another good point right there at the top of the graph. Ooh, I hate how it does that, right? You could just go ahead and draw the graph out a little bit more. You don't have to do all that, but it does. Anyway, so my good points are -4. Ooh, let me turn that thickness down. -4, 0, -4, 0, and 0, 3. So if you want to do the slope formula, you can. My good point here is -2, 0, -2, and 1, 0. And my good point here is the origin and 1, 5. Okay. If I get a graph, I'm doing rise over run. I'm doing that every time. If I get a graph, I'm doing rise over run, and I'm doing it every time. I am going up 1, and then I am going over 4, right? I am going up 1 and over 4. So my slope for this is 1/4. All right, for this one, I go up 2 and I go over 1. So my slope for this one is 2 over 1, which is just 2. And then for this one, I go up 5 over 1, up 5 over 1. So my slope is 5 over 1, which is just 5. Okay? Describe the slope of any line that rises as you view it from left to right. All of these rise from left to right. Okay? All these rise from left to right, and all these slopes are positive. So when it rises from left to right, the slope of the line will be positive. Okay, the slope of the line will be positive.